Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate. It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava, After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about, 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass. But astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy. like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing. Organic molecules. The galaxy in question has a long name SPT-041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name. A polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the sun? Did the black hole swallow it? The sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the sun. Maybe our sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either. So even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the Sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our Sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5 degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life. So the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!
You are waiting for your garlic bread in the oven. While looking up at the stars through your kitchen window, you ask yourself, could you send garlic bread to space? And more importantly, could you still eat it if it came back? Some mighty important questions. Usually, when it comes to garlic bread, there are only two things people care about. Do we want cheese on it? And, oh yeah, eating it. That mouth-watering garlicky taste, combined with the soft, warm bread. Okay, focus. How are we going to send the bread to space? Given that NASA's first space shuttle cost roughly $49 billion, I don't think they'll allow us to borrow a rocket ship for the day, since they may have, more important things to do. I know, it's hard to believe that some people don't take garlic bread as seriously as the rest of us. Don't worry though, all we need is a balloon. Not the kind of balloon we're used to being around at things like parties, where you're surrounded by pizza, burgers and bread buns, hot dogs and bread buns, and cake. I think bread might have too strong of a hold on me. Anyway, the kind of balloon we need is a weather balloon. A weather balloon is explicitly designed to reach high altitudes of up to 24 miles. It carries instruments beyond our atmosphere to send information on temperature, humidity, wind speed, and atmospheric pressure back to us. A French meteorologist, this guy, first started experimenting with them in 1896, and his work led to the discovery of the stratosphere. I wonder if he'd been proud of these balloons now operating as an extraterrestrial taxi service for our garlic bread. Maybe not, but I'm sure he'd be delighted knowing that hundreds of people worldwide today release these balloons for their own experiments every 12 hours. Most standard organizations believe that space officially starts at the completely arbitrated Kármán line, over 62 miles above us. Sending the bread into orbit would require a speed of tens of thousands of miles an hour. Without our rocket ship, which conventionally travels at a speed of 17,000 miles per hour, we won't be able to get the bread that high or to travel at that speed. Okay, no, you can still keep the rocket. I'm happy with my amazing weather balloon, which, by the way, will still get us a third of the way to space, bringing us to the area known as the edge of space. Given that the atmosphere up there is so thin, about 1% of the pressure at ground level, it's really not that bad of a substitute for actual space for this test. I was never comfortable with being over 62 miles away from my dinner anyway. So this works much better for my food abandonment issues. Oh, my ears! I can already hear you at your computer screaming, "What is this guy talking about?" I've seen videos of things like pizza being sent to actual space before, using a similar method. Why should we settle for the edge of space? Well, many cameras operating in those videos to document the object's journey use a fisheye lens. This lens exaggerates the Earth's curve compared to what it looks like at those heights, giving off the illusion that the camera's closer to space than it is. Glad we settled that. Unlike if I were to ask you which is better, pizza or garlic bread. Moving swiftly along, thank you. Now that we've got our weather balloon, to which we've reluctantly attached our garlic bread, the moment for takeoff has arrived. We launch the garlic bread to the sky and wipe the tears from our cheeks as we watch it disappear beyond the clouds. In comparison to a rocket, the pace of our balloon may as well be that of a tortoise, and it will travel at a speed of over 1,000 feet per minute. So, a good way to distract ourselves from the sadness of our bread's departure is by asking ourselves what the garlic bread's in store for during its journey. Well, in 2 hours, our weather balloon can rise above the clouds higher than the paths of jet planes, passing through the ozone layer in the stratosphere and reaching altitudes of 22 miles or higher. The balloon will endure temperatures as cold as minus 90 degrees centigrade, meaning we'd better have a microwave on hand should it make its way back to us. The balloon will expand as it ascends, from 6.5 feet up to 26 feet, because air pressure decreases as the balloon climbs higher in the atmosphere. What happens next would be a truly satisfying experience were my food not being put at risk as a result. Our weather balloon pops. And just like that, our garlic bread will begin the descent from the skies. Wind conditions dictate how far from the launch site the bread will land, but we can expect it to turn up no more than 75 miles away. As is the case for experiments with weather balloons, a parachute is attached to the cargo, which will help ensure the bread's safe return and a reunion with its best friend, my stomach. Some say it's a one-sided friendship. Even though it's this stomach of mine that's currently making animal noises from starvation. It's actual animals who now pose a threat as potential predators of snatching our dinner. Engineers have designed packaging for exercises like this, equipped with GPS and a servo. This packaging will close shut approximately 3,280 feet above the ground. It will protect the garlic bread from unwanted landing spots and the various jaws of the animal kingdom, dramatically increasing the likelihood of being able to eat the garlic bread if we can relocate it. In all actuality, weather balloons used for experiments like this are doing more damage to wildlife and nature than vice versa. Marine animals like turtles often mistake the remains of weather balloons in the water for jellyfish and eat them, thinking that they've just got themselves an easy meal. This is damaging for these animals, given the components of these weather balloons contain rubber and battery acid. Arguments have been put forth that weather balloon testing is ultimately another form of littering. If this video inspires you to try and send some food to space using balloons, keep this in mind. So, the hunt is now on, not for any wild animals, but ourselves. What's that saying though? Fail to prepare. Prepare to go without that fantastic piece of garlic bread that you've just launched into the edge of space, which you're now on your way to reclaim? Or is it just preparing to fail? It doesn't matter, as suggested by the parachute and protective packaging. We're doing neither. To ensure we could find the bread once it landed, we attach radio trackers to the balloon before launching it. These send a signal with a GPS position to the ground, which is then put on a map for us to chase, giving us a good idea of where the garlic bread will be found. Man, I love technology. And just like that, the moment has arrived. We've found our garlic bread intact. And after some moments of passionate hugging and loving strokes, I'm ready to take a bite. So, was the wait worth it? How's it taste? And can you eat it? Yes, you can. But the taste? Not that great, actually. And despite mentioning it earlier, I forgot to bring my microwave. The bread's been frozen from the frightening temperatures experienced on its journey. And I actually mean frozen. The bread itself has an icy middle. But before we can even discover this, we'll notice that when we go to rip a piece of the bread off, it doesn't tear as normal. Instead, it snaps off, as if we've just broken a piece off a twig. We can even hear the clicking noise. My warm, soft bread is no more. You'd be better off keeping this for dessert in the event you run out of frozen ice cream. On second thought, let's just throw it in the trash. Nonetheless, it's pretty cool that we were able to send this garlic bread to the edge of space and still end up eating it, right? Before I pass out from starvation, I'm going to the store to buy some more, which I definitely won't be sending to space. Why don't you let us know in the comments if there's any food you'd like to send to space for seasoning before eating?
The constellation Orion is the brightest one in the sky. Orion is also in the night sky during the winter months when it's dark for the most hours. This makes Orion the most recognizable constellation to almost everyone in the world. Most stars don't seem to move too much or change their positions in the sky. This is not because stars are static. It's because our sun is moving along with them at about 483,000 miles per hour. It's a grand parade orbiting together around the Milky Way. The three stars that form the asterism, or star picture, of the belt of Orion have appeared in the same position for many thousands of years. There's a theory that the ancient Egyptians used the belt stars of Orion as a template for the placement of the three pyramids of Giza. The brightest star in Orion's belt is the middle one, called Al-Nilam. That's where the 481-foot-high Great Pyramid of Khufu was placed. To Khufu's west side, and in precise alignment with it, stands the 471-foot-tall pyramid Khafre. That's exactly where the star Alnitak is directly aligned to the bright middle star of the belt. To Khufu's east side, where the dimmest star of Orion's belt, Mintaka, is slightly offline with the other two stars, is the smallest pyramid of the three. Menkaure is 213 feet high and slightly offline from the other two pyramids. This one example serves to illustrate the profound impact that the constellation Orion has had on human history. Orion's heroic-sized figure inspired the ancient Greeks to create a tapestry-like story. It involves 6 other constellations spread across the winter, spring, and summer sky. Let's see what this story tells us. Orion is pictured as a hunter. Back then, hunting was a big deal. Hunters supplied food. So there's a lot attached to this constellation, the whole food chain in fact. In the sky, Orion is in combat with the constellation Taurus the bull. Except, Taurus is not really a bull, it's an auroch. Aurochs are extinct now, but they were once plentiful in Europe. Standing 6 feet tall at the shoulder with long pointed horns, aurochs were powerful and fearsome creatures. There's a cave in the country of Spain that is filled with gorgeous paintings of aurochs. These pictures date back to 15,000 years ago, exquisitely drawn with inks that have not faded over the course of 150 centuries. The bulges in the rock stand out in 3 dimensions as the shoulder muscles of the aurochs. The constellation of Taurus, the auroch, is also in the cave, with the famous star clusters, the Pleiades, on its back, and the Hyades on its snout. The internet has a thrilling virtual tour of this Cave of the Bulls, full of aurochs. Maybe it should be renamed into the Cave of the Aurochs instead. Recently, the full DNA signature of an auroch was recovered from a well-preserved auroch skeleton, and scientists hope to breed these animals back into existence. Good luck and best wishes to this attempt to revive an extinct species. Aldebaran is the bright red giant star that marks the eye of Taurus. Bulls, when angry, always get this blood-in-the-eye look. Does it make you wonder why the bullseye on a dartboard or archery target is always red? Creeping up behind Orion is Leo the lion. Lions don't just live in Africa in times long past. The Cave of the Bulls in Spain has a painting of Leo the lion. Yep, these prehistoric people were drawing the constellations of the zodiac. But that's another story for another time. Orion gets rid of both Taurus and Leo. And then the story gets interesting. Orion claims in his moment of triumph, "I can defeat any animal I want." Orion's boast becomes the center of this sky drama when Gaia, or Earth, decides to get involved. Orion's words resounded throughout the world. This may be at the time in prehistory when civilization was changing from a nomadic hunter-gatherer tribal society to an agrarian society. The latter developed villages and towns 12,000 years ago. The human population was increasing, and food supplies were diminishing. Something had to be done about Orion and all the hunters, or social development would be stymied. Now enter Gaia into the story, but not into the sky. There is no constellation of Gaia in the sky. Gaia is Earth. Born parentless directly from the elemental chaos, Gaia was the feminine personification of our planet, and the word itself means soil. Brightsiders may be interested in a modern scientific theory that also personifies Earth as a living organism. It's called the Gaia theory. It first appeared in the 1970s. The Gaia theory presents Earth as a biosphere, as if it were alive. The theory claims that all components of the planet work together as one totally interconnected dynamic system. This is called symbiosis, or synergy. Together, they produce the ideal conditions for life. Life adapts to regulate the atmosphere at 21% oxygen, the salinity of the oceans at a maximum of 24.7%, and planetary temperatures at 57 degrees Fahrenheit. To illustrate how life adapts to maintain control of the changes in planetary temperatures, the authors of the Gaia theory created the fictional planet Daisy World. Daisy World is completely covered by white and black daisies. When the sun becomes too hot, the black daisies start disappearing, while the white daisies increase in population. The whiteness of these flowers reflects sunlight, and the planet cools down. If the sun isn't hot enough, the white daisies reduce their population, and the number of the black daisies grows. The black flowers absorb sunlight, and the planet warms up. This is Gaia at work. It's basically the same principle that created oxygen and produced the ozone layer in the atmosphere. This layer helps to block the harmful ultraviolet light from the sun. Scientists have been slow to accept the Gaia theory because of the lack of convincing evidence. But these days, we have self-learning AI supercomputers. They can probably make it possible to integrate Earth's biological and geological systems. This way, we might get a clear picture of how the planet functions as a self-sustaining biosphere. Wouldn't that be something? Now we can go back to the story of Orion and see how Gaia took care of the problem Orion's boast created for the planet. Obviously, Gaia couldn't send animals fiercer than a lion or an auroch to subdue Orion. So, Gaia went small. She chose a poisonous scorpion to do the job, and it did the job. In the summer, the constellation of the Scorpion crawls at almost the same latitude as Orion's foot. The scorpion may be a small animal in the same arachnid family as spiders and ticks, but in the sky, Scorpius is the 33rd largest constellation out of the 88 of them. There is a general rule that the larger a constellation is, the longer ago it was created by early star watchers. They had their pick of stars, first come, first served. And so, they made large constellations first and little constellations later. By the way, if you were the first in line at a buffet dinner, wouldn't you take big helpings and let the end of the line have the scraps? Think chocolate cake. Oh, sure, I'll only take a little piece. Nah, I don't think so. In this story of Orion, we have a collection of large conspicuous constellations like Leo, Taurus, Orion, and Scorpius, which confirms the great age of the story. 3 smaller constellations, Lepus the Hare, Canis Major, and Canis Minor, Orion's 2 hunting dogs, complete the Orion star tapestry and add an interesting subplot. What we have then is a fable of 2 different worldviews or cosmologies, that of Gaia and that of Orion. One is feminine and the other is classically masculine. One is committed to dominating the natural world, that's the Orion archetype. The other is committed to the survival of the planet against all circumstances, that's Gaia. The 2 may seem opposed, but perhaps they're meant to be complementary. Look, Orion and the Scorpion are on the opposite sides of the sky, one in the winter, the other in the summer. They act like 2 poles, north and south, of the same magnet, our planet. This is what we see happening these days. Science and technology are becoming more and more sensitive to the natural environment. Myriads of satellites are monitoring the biosphere of Earth. Gaia and Orion are starting to work together toward what the ancient Greeks called kalokagathia, or harmony. That's what we call synergy and symbiosis these days. Let's keep that synergy going strong. The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The Moon won't be able to block the Sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system, but unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the Moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the Moon's? It might mean the Moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying about. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese.
The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up, like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we are even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burned white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for a billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes: a pancake, Brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust, as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you would see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gaia crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat. In space, no one can hear you scream. Or is that, in space, no one can hear ice cream? Well, either way, we know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? Well, the simplest example is guitar strings. Let's pluck one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 761 miles per hour. Then our eardrums begin to vibrate at the same frequency, and the little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope, it's almost a perfect vacuum. And you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? Well, a vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah. Despite all those celestial bodies in space, there's actually no air in between them. No atoms, no particles, nothing, nada, zippo. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 to 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So, of course, with such a low density, these atoms can't push each other. Even if the vibration is very strong, like, I don't know, a supernova, they still won't be able to do that. So, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above the Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet, or at least get close to its atmosphere to hear something. But whatever it is, it would sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it a thick chemical soup. No thanks. So, if you somehow managed to stay alive and speak there, your voice would be very different. It would become much louder, and it would sound deeper. So, if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second, depending on the water temperature. So if you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how your heart works, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything. From scurrying animals to the movement of tectonic plates. Come on, you'd probably say. It's obvious that there's sound on other planets. But didn't you say we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else. And in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light-years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B-flat, 57 octaves below middle C on the piano. You'd have to add another 660 keys to the left on the keyboard. But its frequency is so low that the human ear unfortunately can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air, after all. In a spacesuit, you would hear sounds very well too, including your breathing or blood circulation in a spacesuit. But two astronauts flying side by side wouldn't hear each other, even if they got very close and shouted very loudly. It's quite funny. If you, being an astronaut, bumped into something, it would be very loud for you, but your friend wouldn't hear anything. That's why astronauts use radio devices.
2091, cancel your call, 2879 will handle.
Now, purely theoretically, if you could somehow crawl out of your spacesuit and survive, you'd be able to hear the chatter and noises going on inside the spaceship. But how? So look, we have some air inside the spaceship and it transmits sound. It reaches the metal casing and gets through it. And then, if you leaned against the ship, preferably touching it with your elbow or knee, the sound would be transmitted to the brain directly through your bones, ignoring the ears. Yes, our bones conduct sound. That's how, for example, deaf people listen to music. It's called bone conduction. It's used in some headphones and some other technologies. You can do a little experiment. Hold your fingers over your ears. Shut them properly so that you really don't hear much. Then try to touch a sound source. It can be anything vibrating. For example, a speaker playing music with some part of your body where the bone is close to the skin. Now, watch the miracle happen. You can hear the sound not through your ears, but directly in your brain. But please, don't repeat this experiment in open space. Ice cream? Haha. Now, you've probably heard about things like the sounds of space, where you can listen, for example, to the sounds made by the sun or different planets. How do we record these ones? Easily. There is another way to hear sound in space: electromagnetic waves. In other words, a radio. Radio is the same form of electromagnetic radiation as light. These waves can travel in a vacuum without any problems. Astronauts' transmitters work that way. An astronaut says something to their friend. The sound waves turn into radio waves, reach the other person, and are then converted back into sounds. And this is how we get so-called space sounds. Our planet is actually very loud in that regard. We're sending a huge amount of radio waves into the universe, all radio signals we've ever listened to. It's a pity that they travel only 110 light-years away from us. But I think it's good that we don't hear everything that happens in space. Imagine if sound could easily travel through the universe. We would hear everything, from solar flares to nearby supernovas. Horrifying, right? So maybe we're just lucky. Hey, remember, in space, you can hear ice cream. Chocolate! Vanilla! That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these